Let me start by saying I would really like to get a CNC router, but right now it was simply not in my budget. I used to have an overhead router and it worked great for making duplicate parts, so I thought maybe I could build my own. The video that follows shows my low-cost Overarm Router solution. I have used it myself extensively and have found that it can repeatedly produce small to medium-sized parts quickly and accurately. I started by making a sturdy base with cross bracing to provide a solid foundation for my overarm pin router. I knew that I would need storage for router bits, wrenches, and accessories, so I made a space for 2 drawers. I also added a waste board of 3/4 inch MDF, which greatly added to the strength of the base. Here I show the base support with the cutout ready to receive the main vertical post. The front and back spindle supports are ready here to attach to the Ryobi Plunge router. I was able to securely attach the Ryobi router by cutting slots and drilling and tapping the bottom aluminum plate. I chose the Ryobi Plunge router mostly because I already owned it. Other routers could have been used but may have had to be connected in a different manner. I believe a Plunge router is the best choice for this project unless a person could incorporate a router lift of some kind. I added the top gantry and the gantry bridge support. The gantry bridge support is fastened with 2 screws in pocket holes at the top, as well as a screw in the circular cutout at the bottom. Once the gantry support was fastened at the back, I added the front and back router support posts with the router already assembled in place. I used a right-angle drill attachment to install the 2 screws through the back support post into the gantry bridge support. Once the router post assembly is fastened in place, the side covers, router top guide, and linear actuator can be installed. The side covers have slots and secondary covers to allow for the electrical cords for the router and the actuator. The router cord slot must be large enough to allow the cord to slide up and down easily. Once installed, the router cord will need to have a small loop at the top to allow for enough slack for the full movement of router travel. The router top guide, shown here, is attached to the top housing of the Ryobi router. The linear actuator is connected to the gantry arm at the top and to the router top guide at the bottom. Later, I attached runner pins to the sides of the router top guide that follow tracks in the front and back router support posts. The electronics consisted of a small DC power supply, a digital readout, a speed controller, and a momentary rocker switch. I prepared a control box to hold the wiring and power supply, as well as a mounting point for the actuator controls and digital readout. The digital readout indicates actuator travel speed, not router movement. I tested the up and down travel of the router bit and everything seemed to be working properly. The plunge feature worked well and kept the bit moving smoothly up and down. It seemed a little on the slow side at first, but in practice I found the speed to be ideal. Here you can see the router AC cable moving through the clearance slot in the cover. I have continued making improvements to the Overarm router, making it stronger and easier to use, such as adjustment knobs and additional bracing. If you are interested in building one of your own, please feel free to use this video as a guide and make any changes you desire. Of course, I can assume no responsibility for the safety and operation of any device you build using my design or suggestions. There are a number of ways to attach templates to your stock piece. I have used CNC double back tape, carpet tape, glue, and the painter's tape with crazy glue trick, and I've always come back to the old school method of screws through the template into the stock piece. In general, the other methods work, but I find they can slip from time to time and can gum up your work and the router bits. So I put up with screw holes and even use them to mark screw or fasteners used in the final assembly. So there are my finished pieces. I did speed up the video in places, and the entire process took about 8 minutes. Not super fast, but respectable. The pieces come out pretty much identical each time, and parts don't require very much sanding, which saves a lot of time and effort. Hope you have enjoyed the video. Have an awesome day.